Okay, we've got number 46 from Chapter 11, OpenStax, second edition. What is the freezing point of a solution of 9.04 grams of iodine? This is the solute because it's present in a less amount. Okay. In 75.5 grams of benzene. This is the solvent. It's present in more amount. So we do a little bit of research on benzene in the table. We find out that the freezing point of pure benzene is equal to 5.5 degrees Celsius, and the molal freezing point depression constant, or KF, is equal to 5.12 degrees Celsius per molality. Some other information we need to know about this is that the molar mass of iodine, and you can add up the numbers in your periodic table, is equal to 253.8089, and that's in units of grams per mole. Okay? And of course, we want to use a couple of formulas, right? Molality is equal to moles of the solute divided by kilograms of the solvent. And we also know that the change in temperature of the freezing point of the solution is equal to Kf times m, and we can calculate the temperature, freezing point of the temperature of the solution by using this formula, the pure substance degrees Celsius minus the change in the freezing point. Okay, we'll talk about all of these in turn. So first, we need to calculate moles. So and that's of the solute, okay, the thing that's present in lesser amounts. So we divide by the molar mass here. And let's punch that in on our calculator. Okay. And I get a value of 0.0356. Okay. I need to calculate, so I got moles. Now I need to calculate kilograms. So we have 75.5 grams of benzene. And basically you just move the decimal place over 3 places. Okay, and you might do that with your calculator if to avoid mistakes. There's that leading zero that sometimes can throw students off. So 0.0755 kilograms, okay, is the kilograms. Okay, now we can find the molality. So moles divided by kilograms is what we get there. So 0.0356 divided by 0.0755, and that's going to be equal to 0.472 units of molality, or small m. Now, what we want to do is plug that into this formula here, and I'll switch to a different font color. And so step 4, we want to now start using our freezing point depression formula. Now Kf is going to depend on the solvent. For benzene, the Kf for benzene, we looked that up, was 5.12 degrees Celsius per molality, okay? And we multiply that by our concentration, okay? And the molality cancels, and we get a value of 2.42 degrees Celsius Okay. Now what we want to do, it's very important that you carefully use this formula and don't omit this step. Now, the actual freezing point of the solution, okay, this is the solution, is going to be equal to the freezing point of the pure solvent, that's pure benzene in this case, minus this change in freezing point we've calculated. So we use the physical data here. We know the freezing point or melting point of benzene is 5.5 degrees Celsius. Okay, and we want to subtract this value here, 2.42, and I'll round this off to the tenths place. So 5.5 minus 2.42 is 3.08. I'll round this off to 3.1. Okay. So the freezing point of this solution should be 3.1 degrees Celsius. Thanks for watching, and please subscribe if you found these videos useful and would like to see more content.